All right. No calculator. No phones. No nothing. I want you to divide 91,789 by 84. Okay?
That's fine. Today's not April
We're going,
1st.
we're going old school.
Long division.
I don't even remember how to do
Go for it. So how am I going to go about doing this problem? Old school long division.
You put the big number under the division.
So I put 84 out in front.
Yeah.
Wait, yeah.
And then 91,789 inside.
Yeah.
Okay. Now what?
Then 84 can go into 91 one time. So you put the,
Even before that.
84 cannot go into 9.
84
so
can't go
0.
into 9, so goes a 0 above that one, right? Or nothing goes above that one. Then
You drop the 1 and then it's 91, and 84 can go into 91 one time.
so 84 goes in there one time.
Yeah.
Then what?
You get a remainder of 7. So you put the
Subtract.
Yeah.
Okay.
And then you get 7.
7.
Then you bring down the 7.
Now we bring down the 7.
Yeah. 84 cannot go into 77, so then you put a 0.
84 can't go in there, so that's going to be a 0. Okay. Then what?
Then 84 cannot go into 77. Oh yeah, and then you subtract. And you get 77 still. Then you bring down the 8. Then 84 goes into 778.
9 times.
I thought it was
You get 756. Um,
22.
Yeah.
I put 29.
You bring down
then it goes in
2
2 times.
times.
Which is 168.
61.
And then it's not done yet. It's just another remainder. So you can either make that into a fraction or
Okay. So we could go here that this is 1,092 with a remainder of 61. Or we could say that this is 1,092 and 61/84. Either one of those, right? You could continue as a decimal, but we're not going to. Huh? Fourth grade, maybe?
Yeah, I think so.
5th grade? Never have to use this again? And you lied to them.
I did.
Straight to their face.
Straight to their face.
Yep.
Better go back and see.
Yep. Send them an email
I
saying,
won't
sorry.
let her have that.
You're gonna, no. Okay. Alright. Okay. Today what we're going to do is we are going to be dividing polynomials. And the only way to divide every single polynomial is long division. And it's the exact same way. We do the exact same process where we look and see what the divisor can go into. We make that adjustment at the top, we subtract, bring down, and so on and so forth. So let's get right into it. Okay? So these problems are going to look like two different kinds. So you're either going to have a polynomial, the division symbol, followed by another polynomial, or I think I have one. Oh, I guess I didn't today. Okay? Or we would have it written as a fraction. Okay? So we could also have this written with 3x cubed plus 17x squared plus 21x minus 11 all over x plus 3. Still done the exact same way. Okay? Alright? So how we go about doing this is the dividend, okay, what we're dividing in, goes on the outside, and the divisor goes on the outside, the dividend goes on the inside. So the first one goes on the inside. Now, I will tell you this, before you get too hardcore into this, and most of you are okay. What was that? Nope. Okay? Alright? One, there's two helpful hints that always come into play with long division. One, these problems are going to take up space. Let them. Okay? Don't try and cram it into a small space. Okay? Two, keep stuff organized. Okay? And I'll show you how you should organize stuff. We're going to basically be organizing these problems vertically. Okay? Which means that in this row right here should only be x cubed terms. In this column right, I shouldn't say row, I should say column. In this column right here should only be x squared terms. In this column, whoa, tap the brakes. In that column right there, come on back to me. In that column right here should only be x terms. In this column right here should only be numbered terms. Okay? So, one, these problems are going to take up space. Two, you need to stay organized. Okay? How we go about doing this now. Okay? So we look at the first term, and the first term of this particular problem is x. We need to make that become 3x cubed. How would I multiply x, or what would I multiply x by to get 3x cubed? 3x squared. Now that's a squared term, right? So that's going to go in my squared term column. Then down here, I'm going to take 3x squared, and I'm going to multiply it by x plus 3. Because that's what we did. You took whatever that number was up top, and you multiplied it by the number out in front. And then that's what you subtracted. So that's going to be 3x cubed plus 9x squared. Agree with that? Then what did you do? We subtracted. So this is the most important part, and the part where the most mistakes will happen. Okay? You need to subtract that whole thing, so you are going to change both of the signs, or all of the signs in that next colored line. You've got to change them all, not just the first one. Both or all of them, because sometimes you might have 3 terms there, need to be changed, not just the first one. Okay? 3x cubed minus 3x cubed. 0 goes away. That's what we want. We want that to go away every single time. 17x squared minus 9x squared. 8x squared. Then, in the numbers, you took the next number and you brought it down, correct? Well, here, Now you're going to take the next term and bring it down. Then, on the back of all shampoo bottles is the directions: rinse, lather, and repeat. Okay? Right? So we need to rinse, lather, and repeat now. Okay? So now I need to take x and I need to make it look like 8x squared.
Plus
What am I going to be multiplying by? 8x. That's an x, so we're going to put that in that column. 8x. Down here, I'm going to multiply 8x times x plus 3. And that's going to be 8x squared plus 24x. And I need to subtract them, so I need to change both of those signs. 8x squared minus 8x squared. 0, that's what we want. 21x minus 24x. Negative 3x. Then, bring down the minus 11. Now I need x to look like negative 3x. Negative 3. What do I need to do with those? Change those signs. Negative 3x plus 3x. Negative 11 plus 9. Negative 2. Yeah? So here is how we would write that then. We could write that as 3x squared plus 8x minus 3 with a remainder of negative 2. Okay, that's possible. But if we need to write it in polynomial form, which 9 out of 10 of your answers in this kind of a problem are going to be written in polynomial form, we're going to write it as 3x squared plus 8x minus 3 plus negative 2 over x plus 3. Yes, sir.
I remember last year trying with this, we did it kind of similar, we did it a little different way. I did it exactly like it, but you know, the top, the first, yeah. You know what I'm talking about?
Mm-hmm.
Like, can you show us
How do you do that?
Nope.
Can we do it that way?
Nope.
What if we do it that way?
You'll be wrong.
But it's our work that way. And we get the same answer.
But if the directions say do it using long division, which all
Does it
of
say
your
that?
directions say you do this using long division, you've got to do that. See, because what you're talking about is called synthetic division. Okay, right? And that only works on certain division problems. This you need because it works on all division problems. Okay, right? So that's why, yes, we will get to it. We'll get to it next week. Okay, but right now we need to learn this because we need to have this tool in our toolbox in order to do all division problems. Because synthetic division doesn't work if, I think I got one. No, I don't think I have one today. I think I have it. This one. Yep, I like this one. Synthetic division doesn't work in this one because we can't set our divisor. divisor equal to 0 and get one number. Yeah. So that's why we can't do that all. Okay? Other questions? All right, let's go to the next one. Now, the downfall with this, this goes into synthetic too, is that sometimes we have to modify the dividend before we can do the actual division. Okay? Meaning, we've got to have our dividend, the one that's inside the long division, has to be in standard form with all of the terms represented. Okay? What I mean by that is x plus 3, yes, is going to go out here. X cubed plus 0x squared minus 4x plus 6 has to go inside. Because I've got to have that x squared column. If I'm going to be organizing my work, I need to have that x squared column. Now that I've got it set up, you do this one. Go for it. I got x squared minus 3x plus 5 plus negative 9 over x plus 3. Questions, comments, concerns? All right. Done the exact same way. Even though now we're dividing by a trinomial. So the divisor goes on the outside. Dividend modified to have the 0x in it because we need to have all of our terms represented. We look at first terms So I need x squared to be x cubed. So that would be multiplying by an x. I take that x, multiply it by my divisor. X cubed minus x squared minus 2x. And I change all of the signs. What was that? Oh, gotcha. Like, I should have a 2. I'm like 2x there. This one should be a 3, is what you're saying? Gotcha. Goes away. 4x squared plus 2x. Then I drop the minus 7. Now again, I try and make my first terms be the same. So x squared to 4x squared would be multiplying by positive 4. X squared minus 4x minus 8. Change all of the signs. Six x plus 1. So the answer here would be x plus 4 plus 6x plus 1 divided by x squared minus x minus 2. One more example. You try that one.
You try to write here. Yeah, very, very good. I also wrote it out. Wrote it right.
2x to the 4th. There's no x cubed term. Minus 13x squared. There's no x term. So this would be 2x cubed. That's going to be 2x to the 4th plus 6x cubed. Change and change. Gives me negative 6x squared. Drop. This would be negative, correction, that would be negative 6x cubed. Negative 6x squared. Change gives me 5x squared 5x. Change and change gives me negative 15x. Drop. Change, change, gets me a remainder of 0. So this one's ends up being 2x cubed minus 6x squared plus 5x minus 15. Does anybody know what that means with having a remainder of 0? What does that mean? Not that it can be factored, that x plus 3 is a factor of it. Right? So x plus 3 would be a factor. So x plus 3 times 2x cubed minus 6x squared plus 5x minus 15 ends up being our original dividend. Okay? Tomorrow is a Chromebook and earbuds kind of a day. Okay? So there will be a video to watch on Canvas again tomorrow. The beige, we're going to go with beige this week. We'll call it beige. Homework is due on Friday, and you also will have a formative assessment on Friday. Okay? I will not be here the rest of the week, which is why it's a Chromebook and earbuds kind of day.